Hey, what is going on everybody? Thanks for checking out my video. We are doing a build video today. I'm doing a 7-inch long range build. So I'm going to take you through step by step how I put this thing together, and then I'll have some first flight footage as well. All right, let's run through the parts real quick before we get started with the build. Starting off with our frame here, I went with the HGLRC Rekon 7. So this is a 7-inch frame, primarily for long range builds. For electronics, I went with a T-Motor F7 55 amp Pro 2 stack. It is a 55 amp ESC, F7 flight controller, and the flight controller is set up for the O3 Air unit. It's got a plug in it, so you don't have to solder anything as far as the O3 is concerned. Speaking of O3, this is what we're using for our video system. We are doing HD, so I picked up this DJI O3 Air unit. And also going on the O3 Air unit, I decided to get some longer antennas than the stock ones. So I went with these Foxeer Lollipops. There's 2 of these in here. Decent length on these left-hand polarized to match my left-hand polarized goggles. These should work well. More antennas. I went with these Flyfish RC Osprey antennas for my goggles. I am running the DJI goggles V2. So I picked up these patch antennas here. These just screw to the front of your goggles and replace your stock faceplate on the front, and it's got 2 patch antennas on the inside here. I'm not sure if this will make my range better or worse, but I think patch antennas are better for long range, so we'll see how these do. GPS. We are doing a long range build, so of course you're going to want a GPS so that if you have any type of emergency or you lose signal, that it will at least fly back to you for the most part. Nothing special here. I just went with this GEP-RC GPS. Okay, and for our receivers, we're going to be running Express LRS. So what I've got here is 2 different options of receivers. This is a Betafpv Super D diversity receiver. This one over here is from Radiomaster. I think it's the RP3, but I'm not sure. I'm still undecided on which one of these diversity receivers I'm going to go with. Either way, both the antennas are too short, so I bought these TBS extended immortal-Ts. Along with that, I just recently purchased this radio. This is the Radiomaster Foxeer. This is the Express LRS version, so it's got internal Express LRS, and it goes up to 1 watt on here. It's got an internal fan. And for the motors, we are going with these Brotherhobby Avengers. They're 2808 1500 kV. These are some big motors. These things are massive. I'm really digging the black. There are no frills, you know, it doesn't look like a cool bell design or anything, but I think they're nice. So these should work out well. We got a battery here. This is a G&B 2800 milliamp hour lithium polymer battery, 6S pack, because we're going to be running 6S. This is not necessarily going to be used for my long range flights. This is more of just a kind of a mid-range pack, or for, you know, doing flight testing and things. I also have a 3000 milliamp hour lithium polymer coming in as well. For our main packs, we're going to be running these 2 bad boys. So what these are is some 6S packs I've made myself using these, what are these? These are Molicel P42As. These are 21700 cells, a little bit bigger than the 18650, but I purchased a bunch of these and then wired them together so they would be 6S voltage. I got the battery leads on the end here. Balance leads are all soldered up. I left the ends off right now because I want to test fit it on the quad before I solder the XT60s on there, in case maybe I want to cut these wire lengths down, or maybe they're nice and long and I want to keep it that way. So that's why the ends don't have anything on them right now. We're going to test fit these on the quad beforehand. I do have a video on these that I can post if you guys want to see how to make these. It's not the correct way to do it, but I do have a build video on these if you want to check out how to make your own long range packs. I'll probably be running these together in parallel. So it'll be a 6S 2P. It'll be an 8000 milliamp hour. Well, 8400 milliamp hour technically, 6S pack. So we should get some crazy long flight time if we're running 2 of these in parallel. All right, first thing, starting with our frame here. Let's get the frame together. There's some nice thick arms, not too bad. I don't know how thick they are, but they're pretty beefy. I'm not gonna show how to put the frame together step by step. I'm just gonna get it done real quick. That way we can move on with the video. If you are using this frame, on the inside of the box, there's a QR code where you can download like a PDF or whatever of the frame. And so this will show you how to put it together. So let's get this done real quick. I would recommend using Loctite when you put this stuff together, especially your frame parts. Use blue Loctite, don't use red, otherwise it will never come back apart. But use a little bit of blue Loctite so that things stay tightened down. This is about where we're gonna be for right now until we get the motors on. This frame comes with these bracing arms, and I plan on using them because I think maybe they will just help stabilize things and maybe cut down on vibrations. I'm not sure. It does come with some hardware, but these screws are not gonna be long enough to go through both the arms and the brace. So what I've got here is I've got this package of M3 hardware. I just got this off of Amazon. It comes with a bunch of different sizes of M3 hardware. We've got an M3 by 12, and the M3 by 12, when you put it through the bracing arm and then through the main arm, if you can see, there's like almost no thread sticking out. There's barely any thread sticking out, and that's just not enough in my opinion. I don't trust that. It's gonna tear the threads out of the motor, and it's not gonna be good. So the next size up is an M3 by 16. And then when you put those through, obviously now you've got a different problem where there's too much threads and you're gonna be contacting the windings of the motor. The 12 is too short, 16 is too long. So what I've done here is I've taken the M3 by 16, and this kit comes with nuts too, and I've just put a nut on the bottom to basically act as a washer. That way, when we go through our brace and our main plate, or our arm, we have the perfect amount of thread sticking out for the motor. Basically, if you could see the threads next to the motor mount, it comes just flush to the top of the motor, and that's exactly what you want. It's perfect. So again, I recommend putting just a dab of blue Loctite on these motor screws before you tighten them down. All right, so there we go. We got one motor on. Obviously, when you put the motor on, you want to make sure that when you bolt it up, the wires are facing this way, running along the arm. You don't want it running, down this way or out the other way. You want the wires running down along the arm like that. You can see the little nuts on there for spacing, and that brings the top of the screws basically exactly flush with the motor mount there, so it doesn't go up and touch the winding. And there it is. We got all the motors on. Now, I guess the next step would be to get our stack mounted, or at least the ESC on. So we're going to get the ESC on so that we can measure and cut our motor wire lengths and get those soldered to the ESC. All right, so we got a beautiful stack here. Look at that. That is nice. The stack came with screws. Came with these 4 screws. I think these are much longer than the stack screws that the frame came with. So yes, these are way too long. This stack screw is literally coming through the top plate here. It's coming out of the top plate. So those are definitely too long. So we're gonna use the stack screws that came with the frame. The ones that came with the T-motor stack are just a bit too long. So if you look there on that screw for the stack, I have a nut on the very bottom of it, actually holding it to the frame so that it's a solid structure. You don't want to put your screw through and then just slide your stack down on it and then put a nut on it, because the whole thing is going to be wobbly and you're going to have a bunch of weird vibration and movement in your gyro, your flight controller. It defeats the purpose of having soft mounted stuff. It's just not going to be good. So anytime you have stack screws, you're going to want to actually secure it down with a nut so that the screw is solid, and then you let the gummies do the work of, soft mounting everything. I'm going to have to put some gummies in this thing real quick. All right, so now we got all the gummies in there, and next we need to put the ESC on and solder up our motor wires. Okay, so your O3 Air unit's gonna be here, your ESC is gonna be here. Typically, a lot of people would mount their ESC like this, where your XT60 would be coming out the rear, but because we have the O3 right here, we're not gonna have room at all to run an XT60 out the back. I suppose you could cut the wires to whatever length and kind of run them out the side this way, but I don't want to do that either. Another option is to mount the ESC sideways like this and then have the cables run out the side like this. Again, I don't think I'm going to do that. I think what we're going to do is we're going to face this actually backwards to where the XT60 is going to be running out the front, because we're not going to have anything up front here. Actually, we might have a buzzer in here too. I think it'll be fine. Basically, here's the setup. You're gonna have your O3 right here, and the top plate is gonna sit about like that. And there's a spot right here for the XT60 to come through. So we can have it like this, solder on our wires, and the XT60 will come around like this. We can plug our batteries in, and all good. Now the ESC is numbered motors, motor 1 here, motor 2, motor 3, and motor 4. But none of that really matters too much because we can change that later on in Betaflight. We're gonna have to make sure all of our motor directions are correct and it knows which motor is which. So you can mount this however, really it doesn't matter. You can change all that stuff later in Betaflight. Now that we got that figured out, we can go ahead and tin all of our motor pads on both sides. Then we will measure our wire lengths, cut our wires, and tin those, and then get them soldered to the ESC. All right, so at this point, before we tin all these pads, I'm just gonna measure and cut wire lengths so we don't have this crazy mess of wires everywhere. So I like to run my wires nice and flat on the arm. So yeah, I'm gonna run mine nice and flat along this arm like that. This furthest one out, so we've got them in a row, or the closest one to the ESC is gonna go to the furthest pad here. And then the next one in the middle is gonna go to the next closest pad in the middle. And then the last wire is gonna come around and go to the last motor pad here. So that's how I'm gonna run mine. Always cut them a little longer than you think they're gonna need to be, and then you can deal with it later when you're actually soldering it on. If you wanna cut it down further, you can do so. Okay, we'll cut this. Keep all the wires you cut, even small wires like this. I try to keep all my wires, just have extras. You never know when you're gonna need stuff. I use like these small wires all the time for fixing things. All right, now that we gave our quad a nice little haircut, a couple of things I would recommend for this. This is like some sticky tack, blue tack, whatever you wanna call it. Stick it to whatever, take your wires and stick it down. That way you don't have to hold stuff in place and it'll hold it there for you. It's really nice, super helpful when it comes to soldering, stuff like that. I got this on Amazon. The bottom plate is steel and it's pretty heavy. It's got some rubber feet on the bottom. It came with a few of these little bendy arms with little grips on the end. Have no idea what these are for, but it came with these as well, so cool. But yeah, it's all magnetic and it sticks to this base. That way, again, you can, you know, put a wire in there, do whatever you need to do, and it will hold the wire in place. So let's tin all the motor pads. We're gonna do that first. Basically, we just wanna get some solder on these pads. And before everyone in the comments yells at me about using flux, I don't have any flux and I don't care. I'm sure they'll be okay. So we got the one side done, all good. Flip it around, get this other side done. I suppose while we're at it, we could tin our battery pads. Our negative pad looks a little like junk, but that's okay. I think it'll be fine. or it won't, but probably will. For the wires, typically, as far as stripping the ends off, you want to strip like a very small amount, just enough for it to have good contact with the pad. You don't need a huge length of wire, because if you have a bunch of exposed wire, it's going to touch other stuff. You're going to have issues. So you only need to strip a small amount. It's just about all you need to make contact with the pad so that you can have a good solder joint. So not a whole big chunk of wire sticking out, just a little bit, enough to solder on and have good connection. Make sure you don't cut through the actual wire. You just kind of crush the insulation a little bit, strip it back, all good, whatever works for you. You're going to want to tin the wire. So basically you just get a little bit of solder on the end of your tip here. You kind of just touch that to the wire, hold it there for a sec and heat it up. And then the solder should flow into the wire. We've got all those wires tinned and ready to be soldered to the motor pads. Okay, so now that we've got all of our motor pads tinned, all of our motor wires are cut to length and they are all tinned as well. We could solder these motor wires up, get that done. So it really doesn't matter which one goes to which pad, as long as obviously you're doing these three here go to this motor, these three back here go to this motor, and so on. So it's the three pads that are closest to that motor that you're soldering to. But as far as like which wire goes to which pad, it doesn't matter. You could mix them whatever way, and it won't really matter, because once you're done and you configure this in Betaflight, you can change motor direction. As far as if you're doing it the way I've done it, or the way most people do it, you already have your wire lengths cut. So like this closest one to the ESC, the first wire is going to go to the furthest pad. Second one's going to go to the middle pad, and then the furthest away is going to go to the pad here. So that's how we're going to do that. I think what I'm going to do here is start with the closest in, because if we start with the furthest out, you're going to end up like covering up the other pads, and it's going to be harder to solder. Okay, nice. That one looks good. There's our first one. How's it look? Yeah, I think that looks good. They're all kind of in line there, but I think that'll work out well. Okay, so I just showed you basically how to solder these up, or at least how I'm going to do it. And once we secure everything down, I think the wires will sit nicely, just like this. It'll look really clean, real nice. I'm gonna solder these up real quick and then we'll move on. Okay, so there we go. We got all of our motor wires soldered up. Looks good. All those, very nice. Other side, very nice. Let's get our battery leads on and capacitor. This is the capacitor that came with the T-motor stack. Yeah, there's a spot, there's like a little hole in the frame here. So the small one will fit in this frame hole, and we can solder that up, and that way it won't be like, you know, we should be able to like mount it flush or whatever in the frame. You've got one side of this band that's shows a negative symbol on it. The other side is just blank. I think that's pretty standardized for all capacitors. That way you know this one's negative, so obviously this side has to be positive. That's fine for now. We need to get our battery lead on, and what I'm gonna do here is, I'm just putting the top plate on real quick so I can kind of measure, test fit this. Okay, so I made a slight mistake there by cutting that XT60 way short. I decided to go a different route as far as my battery cable length. I'm gonna need it to be pretty darn long for kind of my battery setup, or at least the plan for my battery setup. So we're gonna solder on this extra long one, and I'll show you later on kind of why and what's going on. But you know what, let's do this negative one first. This negative lead is going to be an absolute nightmare. I literally cannot get this thing hot enough to solder. I got nothing. I had a terrible time getting that negative lead to actually solder to the pad here. I'll try to show you. It doesn't look super great, but I know it's soldered and I know it'll hold. It'll be fine. It's well soldered. It just looks like garbage. Part's done. The positive is easy, no big deal, but getting that negative on there is so difficult. Yeah, I mean, they're both solidly on there. I'm not worried about them coming off. The way I'm gonna have my batteries set up, I'm gonna want a really long lead like this so that I can strap it how I want to, as far as having the batteries on here. You know, I can strap it up here. Oh boy. Okay, so now that we got our battery leads on, our motors are all soldered up, that's all good. The next thing I'm gonna do is, I'm just gonna quickly secure these motor wires so they're not kind of dangling around. Kind of just like that. That's how I wrap my stuff. Very minimalist. I think it's a clean look. All right, there we go. Got some tape on the motor wires. Now it's a bit more clean. The next thing we're gonna do is install our flight controller. So it came with these little tiny these little plastic spacers. So we're just gonna stick one of those on each of these posts here. Okay, so we got those spacers on there, and now we can mount our flight controller. So the ESC is technically backwards, so the battery lead's coming out the front. If you look at the flight controller, there is a white arrow right here, and that's your forward direction. So since our ESC is backwards, you'd think you'd have to mount your flight controller backwards as well so that your plug will fit, because this is a plug here that runs from the flight controller to the ESC. You'd think you'd have to mount it backwards so that your plug will fit in both ends as well. And then again, in Betaflight, you can tell it that the flight controller is like 180 degrees out, and you could do it that way. I'm not gonna do that though. I've already tested this, but basically I can mount the flight controller facing forward. I can plug this in and then have the wires run between them. The wires will run underneath and then come out the other side, and they'll plug in, and it's not too stretched or anything, so that'll work fine. So we're gonna mount the flight controller the correct way. When we look at a wiring diagram, you can see in the rear, you've got a 10-volt ground UART2, which is TX and RX2, ground S-bus. This is the plug for your DJI O3 Air unit, so that's gonna plug directly in, so it'll be nice to have it in the back where the O3 Air unit's mounted. All right, I'm gonna start here with my buzzer. Here's our buzzer, and it came with some wires. And on the pads, we can see buzzer negative, 5-volt ground, and LED. And on the wiring diagram and the pads here, we've got LED, B negative, 5-volt ground. Yeah, you know what? We're just gonna do the buzzer, and I'm not worried about the LEDs. So let's untwist these wires here. And we just need red and black. So we can do B negative and 5-volt. We're gonna quickly tin those pads. Okay, there we go. Buzzer negative and 5-volt on there. And we can trim these wires down later. We can do the GPS next. Our GPS has a plug on one end and the wires on the other end. So it's gonna mount obviously in here. I know it's a little shaky and wobbly. It's not really the right size, but we're gonna make it work regardless. And then there's a hole back here, probably can't see, but they go through, there's a hole for the plug that runs through the bottom. So I have it like half plugged in right now, just for reference. And this is gonna sit on the back here. And then so these wires are gonna run, you know, presumably here. And then we're gonna leave a little slack and we'll twist them up. But I think, yeah, so I think about this length is good. So we can go ahead and cut these here. Nice. All these are tinned, good to go. Okay, so again, looking at our wiring diagram, we have R4T4, 5-volt ground, and we're not using SDA or SCL because we do not have a compass. We don't have a compass. We don't need those. And ground. Okay, I just want to make sure we're putting the wires in the correct spot. Ground is black like it should be. Red is 5-volt just like it should be. And then R and T are yellow and white. So let's just start with one of them. That way we know what we're doing. So RX always goes to TX. So I know you might think like, oh, RX to RX, but that's not what you want because it's a receive. So you want the transmit from your flight controller to go to the receive on the other end. That goes for really anything you're soldering. R always goes to T, you know, and T to R. So this R needs to go to a T pad. Just like that. 5-volt is next. 5-volt's good. Ground, 5-volt, T and V. Ground, black wire goes to ground. Our 5-volt red comes back in, goes to 5-volt. This yellow RX wire from here goes to our T, which means that our R is going to our T on here. So this is good. Now we can do the receiver. So the receiver I'm going to use is this Betafpv Super D. It is a True Diversity Express LRS receiver. Now, True Diversity because some of the diversity receivers is one RF chipset and 2 antennas, whereas this one is 2 separate RF chipsets and 2 antennas. So basically, it's almost like having 2 full separate receivers running on one board going to your flight controller. Came with some wires here, some heat shrink. Not quite sure where I want to mount this yet, but we can at least get the wires soldered up. But if we take a look at our wiring diagram for this flight controller, they want us to use UART5 for the receiver. So R5T5 5-volt ground is what we're going to use for our receiver. Looks good. Okay. Those are all good. Okay, so all of our receiver wires are all nicely soldered. Plug this in, facing this way. Plug it into our flight controller. Thankfully, the wires will reach. So here's kind of how it's looking, right? And you just go like this and they'll run underneath. And we're gonna set it down like that. Boom, there we go. Jeez. So this is R5 that needs to go to a T. There's all the receiver wires soldered up. Looks good. Buzzer looks good. Nicely soldered. So GPS wires are on. Receiver is soldered up. Our buzzer is soldered up. Now I guess it's time to throw on the O3 Air unit. Pull this bad boy out. First thing we can do is actually unscrew this back part here. They're two little Phillips screws. And I'm just taking off this antenna here because we're not going to be using this. We've got some longer antennas that should help us with our video connection. So in the kit of things that come with all the 3D printed parts, this is all the stuff that came with this frame. This one is for your DJI O3 Air unit. So we're gonna throw that in like that. Go ahead and mount this. I'm gonna run the wires underneath. There's a small kind of channel here, and there's enough of a gap on the 3D print that it'll leave you a little channel there for the wires. Just kind of press that down. Plug that in, clips in nicely. I think now I want to install the camera, and that'll give us a better view of kind of where we can put our buzzer and our receiver, because I don't know how much room we're gonna have up front here. The camera comes with like the regular carbon fiber plates, and then it comes with these 3D printed mounts that are for the O3. And the way these work is you match up the pieces, right? You'll see, and then it goes and slides in. There's like a slotted portion right here, so it kind of goes underneath this lip, but it'll basically slide over like this, and then it's gonna sit just like that. The screws that came with the O3 for the camera are too short to go through the plates and the 3D print, as you can see. So what you're gonna wanna do is set those aside. Yes, they're M2 screws. So you're gonna wanna get some M2 hardware that's gonna be the correct length. You're gonna wanna use an M2 by 10. Kind of just cinch these down right now. I'm gonna change the camera angle later. Now, this is starting to look like an actual drone. Now, this does come with a 3D printed mount for a buzzer, but not my buzzer. It's not gonna fit very well. It's for a different buzzer. So the two standoffs here, this is gonna slide down on those two. And then on this side, you'll see this extra like hole right here. That is gonna have a screw. So this will be sitting in the drone like this. And then you're gonna have another screw go through this for this mount, which is an antenna mount, and it's gonna mount to the side like that and allow you to swivel the antenna. I'll show you what I mean later. So now you can see our 3D print right here where our buzzer would go. And what we're gonna do with this actually is we're just gonna stuff it down here. Not a lot of room in this frame, but anyway, we're gonna stuff this down here behind the camera, and it'll work fine. You'll see when it's done. So I think I'm gonna run the antennas this way too, and it'll hold them in place. Just wanna click these into place. There we go. Boom. All right, let's see. Both of our antennas are on there. And we're gonna heat shrink this down. Okay, so everything's basically stuffed up front now because I just can't seem to find room for anything. So if you see up front here, I basically cut the 3D printed part. It had like, you know, pieces running over the top this way. I just kind of cut the top of it open so I could fit the receiver in there. And so I've just kind of jammed the receiver in there, and that'll work fine. Buzzer's jammed up front as well. So that's gonna stay. Once it's in there, it's not gonna come out or anything. Before we can put our GPS in here and plug that all in, we actually need our antennas for the O3, these Foxeer antennas, because these have to go through this 3D printed part first. These have a split in them so that you can more easily do this. The split that the antenna goes through, and then the antenna will go through here, and then as you push it down, it'll squeeze that tighter and tighter. So we'll kind of squish that down. I don't think it matters which one goes where on here either, so you can cross them, do whatever, it doesn't matter. All right, nice, that one's on. Now, you put this plate on here so they don't fucking come off. Crank these down. Boom, looking good. So now we need to do the GPS, and what we're gonna do for that is GPS wire and feed that through. And get that plugged in. Okay. I'm gonna stick that down. Man, that's looking good. Oh, shit. I messed up. Sorry, some of this stuff I just can't get on film because it's just, I really gotta twist and torque some of this stuff to get it to work. But we've got our antenna here. So coming from the receiver, this one antenna that's running this way, and it's going underneath this 3D print here. You can see it coming out the bottom here. And then it's going to this 3D print right here. But it was kind of a nightmare to get this immortal-T to sit in here like this because this 3D print is pretty stiff there, and you don't want to really bend this or like snap it or whatever, right? Like if you kinked it or whatever, if you grab this and went full 90 or 180 and kinked it, you're gonna fuck up this antenna. So that's not what you want to do. So I was really struggling to get this in here, but it's in there now, and so that looks good. That rear antenna is all good. The frame kit comes with these long M2 screws and this kind of odd 3D printed part, and it basically has a hole here. There's this piece that goes through, this screw goes through like that, and then you put a nut on the back side. When you are storing it or transporting it, the antenna will sit flat with the rest of the drone for the most part, it won't be in the way. And then when you fly, you can rotate it so that it's sitting like this so that you can have a better signal. So that's what we're doing right now and why we took off all these parts. So we need a nut. All right, so everything is hooked up. We got the GPS plugged in the back here and it is soldered up. O3 Air unit's plugged in back here, plugged in here. Our receiver is wired up right here and it's wired up here. Our buzzer is wired up. Antennas are on. I think we are ready for our first power up and see what happens here. I've got my smoke stopper here, so hopefully this should cut the battery if there's any issues and I messed up the soldering. This should save us, but I'm always very nervous on the first plug-in. Let's see what happens here though. Let me grab a battery. Okay, we got a red light on this thing. Not really sure what that means, but it's there. So here we go. I think we're good. Powered up, nothing blew up. We got lights on our board here. We got lights on our receiver. We heard beeps. I assume we did everything correctly then. Very nice. All right, so we're pretty much mostly done here. All we got to do now is get our receiver bound and hop into the computer, give it a quick tune, and then we're gonna go test fly it and see how this thing does. So let's do that now. And I've got my Boxer. So we're doing Express LRS. So now I guess we got to bind it.
Welcome to HTX.
Then we're going to go to System and we're going to go Express LRS. And then we're going to scroll down to, let's see, scroll down to where it says bind and check your firmware version right there. It says 3.2.0 is the firmware that came on this. I have not updated or anything. So we're ready to bind there, and I believe when we read the manual for the receiver that we wired up, this says default firmware of the Super D uses Express 3.0.0. Firmware version of the transmitter module must be Express LRS 3.0.0 or later versions. Both the receiver and transmitter model should not have any binding phrase. So this is a brand new receiver. It doesn't have a binding phrase because I haven't done that. And it says that it comes with 3.0 and I'm on 3.2.0. So it says anything 3.0 and later, which is what we have. So technically we should be able to do this kind of the old fashioned way. Instead of using a flash on the computer and binding phrase and things, we should be able to triple power cycle the quad, which will put the receiver into binding mode and then hit the bind button and they should bind up. So you see that double blink there? That means it's in binding mode. Let's go ahead and hit bind. I thought we would get a solid light. Oh, we got a solid light. There we go. I believe that means we are bound.
Receiver still connected.
And I tried to turn it off and it said receiver still connected. So that's a good indication that we are definitely bound with the receiver. I'm out here today to test my GPS rescue function. see how the quad flies, and check all my flight data as far as RSSI DBM and link quality and all that stuff. Probably do a GPS rescue test, and if that works good, then I'll do fail-safe on a switch, and then if that works good, I'll probably do the radio shutdown and see if that works out. Unfortunately, I don't have a way to record OSD, so when I'm flying, I'm just gonna have to call out what's happening. I'm gonna be recording with the GoPro, so you'll have some nice clean footage. We've got the rear antenna here, immortal-T here. These are for our video, and on the side here, we've got this immortal-T that kind of spins up like this. The only thing I'm worried about is the fact that like the GoPro's kind of like blocking it now, but we do have this little hang down piece, so I don't know, we'll see how the setup is. The back corner of the park is about 1,200 feet away as far as distance from me. So that'll be a good distance to see numbers wise, RSSI, stuff like that. I'm gonna be running a 6S 1500 milliamp hour GNB. This is a high volt. Then I have this other GNB. This is a 2800 milliamp hour 6S pack. So this should give us some good flight time. And then I'm gonna be testing my homemade pack. This is a 6S lithium ion. My first test, I'm gonna be running just 250 milliwatts to see what the numbers look like at the farthest distance. With my 5-inch at the furthest distance, I'm at like negative 60 to negative 70 RSSI DBM on the lowest end. So I'm hoping to get the same or better with this, with the diversity antennas. So we're in acro. We're armed. All right, we're flying. Distance from home is about 300 feet. RSSI is about 50, negative 50 anyway. So I'm gonna go ahead and push to the end of the field here. RSSI, DBMs look good. We're negative 70, 69, 64. Yeah, signal is great all the way out. All right, we just hit 3.4 something volts, so I'm gonna come in for a landing here. 1600 milliamp hour, 4.7. Boom. Okay, so total arm time says 637. Max altitude says 72 feet. Max speed 45, that seems good. Max distance flown away was 1,243 feet. Total flight distance was 2.43 miles. Battery is currently sitting at 21 volts. Okay, so now we need to test GPS rescue. I'm gonna throw GPS rescue on the switch. We're gonna be running this GNB 2800 milliamp.
Danger.
Okay, pushing the throttle a little bit, feels good still. Let's do a little bit of a roll. Okay, roll was good. Let's see if we can hit a power loop here. Yep. Power loop was good. GPS in 5, 4, 3, 2, 1.
GPS.
Okay, it's flying back to us. Holy shit. It's really moving crazy. Okay, I suppose that worked. Okay, I'm gonna test a fail-safe. 5, 4, 3, 2, 1.
Fail-safe active.
Okay, that was not good. We just hopped up way too high. Okay, so it seems like we have some work to do with our fail-safe and GPS rescue settings, because that was not good.
Angle mode.
Whoo! We caught that boy. Okay, so yeah, I definitely have some work to do with the GPS rescue settings. And GPS rescue did seem to work. I mean, it definitely brought it back to me. It went kind of crazy far that way, but I cut it off early because I was like, I don't know what it's gonna try to do, if it's gonna mess up with the trees. And then after that, I did fail-safe on a switch and it skyrocketed. It went so high up that I got scared. I was like, something seems off, so I just turned it off. I also don't like how much throttle it gives. Like when it goes into GPS rescue or fail-safe, it goes full throttle, like just gone. So I kind of don't like that either. So definitely some settings I need to change, but for the most part, it actually seems to fly pretty good. Total arm time was 10 minutes. Max altitude was 66 feet. Max speed was 47. Max distance away from myself was 900 feet. Flight distance total was 5 miles, 5.22 miles. Minimum battery was 17 volts. Battery's currently at 20.82. Max current was 94 amps. Milliamp hour used was 3100. This one actually seemed to do pretty good. It worries me a little flying a single pack like this, just because the amp draw, you know, you're not supposed to go over 45 continuous. Curious to see how this thing flies with 2 of these packs on here. That was just running the 1 pack just to test it out. But for my, you know, if I'm really gonna push this thing far, I would be running 2 of these. They'd be side by side. And so we'd have a total of like 8,000 milliamp hours. But I still need to get my amp meter all calibrated and whatnot. So other than that, I think it ran great and I'm happy with the way it turned out. A few kinks to work out like any other build, but yeah, I'm happy with the build. So hopefully you guys enjoyed the video and the flight footage. I know it was a long video, but you know, that's just how it goes with build videos. And yeah, if you guys liked the video, go ahead and click the like button, subscribe, because I'm gonna have more content with this thing. We're gonna be doing some long range stuff, some mountain surfing, stuff like that. Yeah, I'd really appreciate it if you guys subscribe and like this video. Yeah, I'll see you guys in the next video.